Hello, and welcome to another fun-filled math class. Today we're going to continue our proportional reasoning by converting customary measures. And what customary, we have two ways of measuring things. We have customary, which is what we use in America, which is gallon, quarts, pints, cups, ounces, also inches, feet, yards, and miles. If you go over to Europe or South America or some other country, they use the metric system, which is what you use in science, with centimeters, meters, decimeters, kilometers, and all that stuff. So when we're converting between customary measures, sometimes we're converting within customary. So we're talking about going from inches to feet and feet to inches. But sometimes we're also talking about going between customary to metric. And you'll be given charts and stuff to do that. But we do use proportional reasoning to do that. So the learning target is to apply proportions to convert units of measurement between the U.S. customary measurement system and the metric system. So metric is what everybody else uses. U.S. customary is what we use. So if you look at your notes on page 14, you have this nice little chart right here that gives you the approximate values between the customary, which is the ones that are on the left, and the metric, which are on the right. And it's important to note that if you see these two little squigglies, that means things are about, or it's an estimation. And to make sure when you're setting these up, the units in your numerators must match. The units in your denominators must match. So like if I'm setting up inches to centimeters, you want to make sure you're lining them up. Remember, we've always talked about setting up your proportion and labeling what is in your proportion on the left before you get started. So this is going to be really important as you move into this lesson. All right, so just a real quick recap of how we do proportions. So this is an example. Paige ran a 5-kilometer race. What would be the closest distance she ran in miles? So in other words, 5 kilometers is about how many miles? So the first thing we're going to do is set up a ratio with the scale, what you know from the table. So if we go back to the table, we're going to go here and we're going to find miles and kilometers, which is right here. So 1 mile equals about 1.6 kilometers. So if we go back to our notes, they tell us that 1 kilometer is about 0.5 miles. So they gave us that. Sometimes they give that to you in the problem. Sometimes you have to kind of know it. And then we're saying, so we're measuring kilometers over miles. And we want to keep kilometers with kilometers and miles with miles. So our first one is the ratio or the scale that we're using. And then the second one is what we know from the problem, which is that she ran 5 kilometers. Kilometers with kilometers, so we keep that on the top of the ratio. And then we're trying to find how many miles. So the first thing is set up a ratio with the scale, or what you know. And the second one is set up a second ratio with what you know from the problem. So, and then put an X for the missing one. And then to solve the problem, you're going to, as always, cross multiply first and then divide. So let's solve this one and see what we get. We're going to cross multiply. I'm going to multiply 5 times 0.5. And then I'm going to multiply 1 times my x. Okay, so when I multiply 1 times x, this is my x, I get 1x. And then I'm going to multiply 5 times 0.5, or half of 5. So we're going to get 2.5. And then we need to look at what our answer is. We already had kilometers. Our x is next to the miles, so we know that our answer is going to be 2.5 miles. The other thing to make sure is that you're labeling every answer that you have, and make sure your label makes sense. Go back and reread the problem. Paige ran a 5-kilometer race. What's the closest distance she ran in miles? So, and again, we're looking for miles. So make sure when you label your problem that you're indicating what it is that they're asking. So here's two sample problems we're going to solve, and we're going to solve two more on the back, and then the rest of the problems you're going to be solving on your Edmodo quiz. So for the first one, it says if 1 pound is about 0.45 kilograms, how many kilograms does a student weigh if he is 120 pounds? So let's first write down what we're comparing. We're comparing pounds with kilograms. And what we know, it says 1 pound is about 0.45 or 45 hundredths of a kilogram. So 1 pound is equal to 45 hundredths of a kilogram. So again, we lined up our units on the first ratio, and our second ratio they give us is 120 pounds. So pounds are on top, so we're going to put the 120 on top because that lines up with pounds, and we're trying to find kilograms. So again, we're going to cross multiply. Cross multiply, we get 1 times x, which is just 1x, and then we have 120 times 45 hundredths, and when we do that, we get 54. And since we divide, if we divide by 1, we could, but it's not going to change the value. So x equals 54, but what does 54 mean? What are we looking for? Well, if you look where your x is, my x is here, and if you follow it over, it'll tell you what units. My units are kilograms. So my answer is 54 kilograms. It's that simple. Line up your units first, set up your proportion, and then cross multiply and divide as your third step. Here's another sample problem. The happy birthday poster in Dr. Smith's office is about 75 centimeters long. About how many inches long is the poster? So I know we're comparing centimeters with inches. They don't give me the ratio, so I have to look back at my table. Oops, I went too far. Here's my ratio I'm going to use. 1 inch is about 2.54 centimeters. So I got to plug that in. 2.54 centimeters is 1 inch. Make sure you line up your units. And then I have to set up my other proportion with what's given to me. 75 centimeters. Centimeters is on top, so I put that on top. And my x goes where I'm missing my value. Cross multiply. When I cross multiply, I get 2.54 times x, which is just 2.54x, and 75 times 1, which I know is just 75, but I'm going to just show the work. Now to solve, I divide by 2.54, 2 and 54 hundredths on both sides. That gets my x by itself. These cancel, so I have x by itself, and when I divide, I get this really long decimal. I get 2952. Let me move this out of the way. 755,906, blah, 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 blah. It keeps going. But that's what you see in your calculator. I'm going to look at this. 2 is not greater than 5. So I'm just going to go to my tenths place. And so my answer would be 29, or about, I should say, 29.5, and look at what I'm looking at, and it's inches. Label it. Okay, so my answer is about 29.5 inches. So it's that simple. Set up what units you're measuring, then you're going to set up your proportion, cross multiply and divide, and it's that simple. Flip your notes over. There are 6 practice problems on the back. We're going to solve the first 2 together, and then the rest of them you're solving for your Edmodo homework quiz. Okay, so first thing I'm going to do, read the problem and identify. I'm going to use my highlighter tool. I'm going to highlight what I'm comparing. So I'm going to choose 2 different colors because I want to highlight each unit that I'm measuring 2 different things. So it says if 4 meters is about 156 inches, how many inches are in 13 meters? So I have 4 meters and I have 13 meters, and then I also have 156 inches. So if I set this up, I'm comparing meters and inches. So my first ratio is what's given to me in that first part of the sentence. 4 meters is about 156 inches. You want to keep those first two things together as a ratio because that's setting up the equivalency or setting up your proportion of how things are related. And then the second one, I fill in. I've got 13 meters. Meters is on top, so I fill it in. Keep in mind, your answer is not always on top, so you're just lining up your units. Then you're going to cross multiply 13 times 156 and 4 times x. So I have 4 times x is equal to 13 times 156. So 4x, oh, what am I doing? Not 45. 4x is equal to 2028. And then I divide by 4 on both sides to solve. These cancel. And 2028 divided by 4 is 507. So I've got my number. Now I need to say, what does that represent? 507 what? If you could go back up to where your x is, that's in line with inches. So I know my answer is 507 inches. If you want to, when you're setting up your proportion, look at where your x is and automatically set it up and kind of give yourself a little answer bubble, and then all you have to do at the end is go in and write it in. You can do that too, just to make sure you don't mess up your problem. Okay, let's look at our next problem. Melissa's new puppy weighs 48 ounces. What is the puppy's weight in grams? So ounces is customary, grams is metric. So we're looking at screen. So it's ounces over grams. And I don't have anything to look at, so I need to go back to my table and use that as an example. I'm looking at ounces and grams, which is right here. 1 ounce is 28 and 35 hundredths of a gram. So 28.35 in 1 ounce. So let's go back to our sample problem. 1 ounce is 28.35 grams. And then what else is given to me is 48 ounces. So I plug it in. And then all I'm going to do is cross multiply. Cross multiply. So I'm going to have 1 times x, which is 1x. And I'm going to have 48 times 28 and 35 hundredths, which when I do that, oops, equals 1,360 and 8/10. And then I look at where my x is, it's lined up with grams. So that's my answer. It's that simple. The biggest thing is you've got to line up your units, cross multiply, then divide. It's not that hard. So reread the problem several times, and make sure you have the correct answer. And then don't forget, we have a quiz on proportions that will happen with our customary measurement lesson, and then after that we'll start our tax tip discount consumer math unit.